Hello, welcome to another Halo Innovations video. Today we'll be looking at how to sign up and download Fusion 360. To get started, we're going to head over to haloinnovations.ca. There will be a link in the description down below. However, if you go there through Google and you'll come to this page, you'll want to click Downloads CAD/CAM Software. Once you're in the CAD/CAM Software page, you'll want to download Halo Post Processor Fusion 360 and then Halo Plasma Cutter library for Fusion 360 as well. We also have a link directly to the Fusion 360 page. Once you're on the Fusion 360 page, you'll see these two options, Autodesk Fusion for personal use and Autodesk Fusion. We're going to be using personal use today. If you feel like downloading the full version that you have to pay for, go right ahead, but all you need for our purposes is the free version, so we're going to go ahead and download that. Once you've clicked Get Autodesk Fusion, it'll bring you to this page where it wants you to create an account. So just fill out these fields that you see here and then click Create an Account. Once you've created your account, it'll bring you to this page where it's going to ask you to fill in a few more fields. Step number 2 asks for your name, last name, and work phone number. However, work phone number is not actually required. Step number 3 is just about location details. Country, state, or province, zip or postal code. When putting in your postal code, put the space in between. Upon completion of the previous step, you're brought to this page where you can click Download Now. You'll then be asked to sign in. Upon clicking the Sign In button, you'll be brought to this page where it asks you to get a verification email. Once you open that email, click the button, and when you do that, your account will be verified. And now you're finally able to click Download Now. Once you've downloaded Fusion, find where you've downloaded it to, double click the icon, and then follow the on-screen instructions to install it. We'll now cover how to import your tool library and post processor. Now that you've downloaded and installed Fusion, we're going to open it up. It'll bring us to this page right here. This is the canvas that we're going to be working in while we're creating a shape or making a cut pattern. Before we can get started though, we need to go over here where it says design, down to manufacture, and now we need to import a tool library as well as the post processor. Both of these files you would have already downloaded if you went to our website and found them there from the previous section. So we're just going to go into tool library, which is under the manage section right here in the middle. We're going to go to library, right click, and we're going to select import libraries. We're going to scroll down to the bottom here where our plasma cutter library is, and there we go. It's now imported. We have all these different options for different tips, different kerf widths, and these are all depending on what kind of amperage you're using and voltage and that kind of stuff. Now we're going to click on the G here for post library. We're going to be importing our post processor now. So click this blue G, go to local, and then this page with the arrow, select import, and then we're going to choose Halo Post Processor for Fusion 360, open, and there we go. That's all we need to do for that, and now we're going to head back over to design. In this part of the video, we'll be covering how to use Fusion 360 in order to create a simple part, and then how to create a cut file that you can then bring to your plasma table. One of the first things that we'll be doing when we open up Fusion for a new project is saving. We can do that by pressing Ctrl and S on our keyboard, which is the hotkey to save your project. The default perspective in Fusion is the home view, which you can see in the top right corner with the home icon. In today's project, we're going to want to be working from the top-down perspective, which can be achieved by clicking on top of the view cube. This will give us a better access to the X and Y axes, which are the only two axes we'll be using when using a plasma table. Our next step is to create a new component. In simple terms, a component is like a container that holds different aspects of the project, such as sketches and bodies, which we'll be working with in future steps. Creating a new component is widely viewed as a good starting point for any project. After creating that component, you can see in the browser on the left side of the screen that we have created a new component called Metal Sheet. We will now create our first part. To do this, go up to where it says Create, then scroll down the menu and select Box. After doing this, you will be prompted to select a plane to work on. So we'll go ahead and select the X and Y plane, which is the only plane that we can see from the top-down perspective. We want to create our shape slightly off of the center point of the canvas, so that we can easily view the center point when creating our other shapes later. When creating the shape, you will see two boxes with different values, one of which will be highlighted in black. These values determine the length and width of the shape that you are creating. By typing a number, you can set the value of that dimension. After entering the desired value, you can press the tab key to toggle over to the other dialog box and enter a value there as well. Take note that our project is in millimeters, which can be changed by clicking on Document Settings, found in the browser on the left side of the canvas. After finalizing the length and width values, you'll be prompted to enter a value for the height of the shape. Because this shape will be the sheet of metal we're cutting out of, we'll stick with a lower value to help visualize the material that we're working with. We'll now be cutting a shape out of the part that we created. To do this, we'll go back to Create and scroll down to select Cylinder. You'll need to select a plane to work on once again, but this time we'll select the top face of the square part that we created in the last step. Doing this will help us to better visualize the size of the shape that we want to cut out of the part, as well as to make changes to the design. We'll then click on the top of our first part to start creating the cylinder. We'll once again enter a value for the dimension of our shape, only this time it will determine the diameter of the cylinder. After we finalize the diameter, we'll decide on the height as well. If the placement of the cylinder looks good, then we can cut it out right now by making our shape -10 millimeters. However, if we want to adjust the placement, then we can go to Operation and New Body. If you make the cylinder a new body, in order to move it, you'll need to right-click on it and choose Move Copy. A dialog box will open on the right side of the canvas. In this box, you'll need to look for the line that says Move Object and then select Bodies from the drop-down menu. After doing that, mouse over the cylinder and make sure only it lights up. Clicking and dragging the square that appears on the cylinder will let you move it in any direction. After you have chosen the position for the cylinder, you'll need to click Extrude on the toolbar at the top of the screen and select the cylinder. When extruding, we'll enter a negative value for the height. We'll enter -15 millimeters because our plate is 10 millimeters and our cylinder is 5. After cutting the circle out of your first part, if you decide you want to move it again, you can right-click, Move Copy, and this time you'll want the Move Object line to say Faces instead of Bodies. Rotate the camera a little bit using the cube at the top right or hold Shift while pushing in the mouse wheel, so that you can easily click on the inside face of the hole you made. You can then click and drag the box that appears in order to reposition the hole. Next, we want to create a new cylinder inside of the hole that we made, so we'll do the same thing we did before, but this time we want to work on the same plane that our first part is on. To do this, select anywhere that you can see the canvas. Once you select your plane, create the cylinder inside the hole you made in the previous step. We need this cylinder to be the same height as our first part, so we'll need to make it 10 millimeters. Reposition it if needed like we did previously. If we post-process this as is, the cylinder in the middle would fall out after being cut, so we first need to add a bridge to attach the cylinder to the square part. To do this, we'll use the box tool once again. Create a box that connects one side of the square part to the other and crosses over the middle of the cylinder. We can resize and move the bridge before finalizing using the arrows that appear on all sides of it. We need to enter a negative value for our bridge's height, but before we finalize that, we need to look in the window at the line that says operation. Because our part is on top of other parts that we've made, Fusion thinks we want to cut this shape out of our existing parts. Once you're happy with the dimensions and placement of your bridge, we'll go ahead and join it with the existing parts that we created in the previous steps. In this section, we'll be creating the toolpath that you can see on the screen. We will now move into the manufacture workspace. To do this, click the button that says Design at the top left of Fusion, then scroll down to select Manufacture. Before we do anything in this workspace, we first need to change a setting. So click on Setup and then select New Setup. When the dialog box opens on the right side of the canvas, you'll see a green arrow and a red arrow on top of the part that you created. This is a marker for the stock point. If you click the white circle at the base of the two arrows and then the dot at the bottom left of our part, this will change the stock point to that corner. This sets the border for the space in which our plasma table will do its work. Once finished, click OK and we'll move on to getting set up to create a toolpath. You'll need to click the icon that looks like a plasma cutter and says Cutting underneath it. On the right side of the screen, a new box will open up. In that box, there's a line that says Tool. Click on the button that says Select. Once the new menu opens up, you'll need to navigate to Local and then select Plasma Cutter Library, which we imported in the first half of this video. Here, you are essentially just selecting your kerf from the available choices. You'll need to select the tool that has the same size tip as your plasma cutter and make sure that you select one with the same amperage as your plasma cutter as well. We'll now move on to the next tab of the menu called Geometry. In this tab, we need to select the edges of our part that need to be cut out. Moving on to the Passes tab, you'll need to be sure that your settings look like this. Tolerance 0.01 millimeters, sideways compensation left, compensation type in computer, and then also make sure that smoothing is ticked. In the next tab called Linking, make sure that you don't have Keep Nozzle Down ticked. The Halo Plasma table has a torch height control included with it, and this is only for tables that do not have a THC. We want both lead in and lead out to be ticked, as well as same as lead in. Our lead-in radius will be 15 millimeters, the lead-in sweep angle will be 60 degrees, and our lead-in distance will be 0 millimeters. We will then look to the bottom of the window where the positions heading is. If we click the button beside the preferred lead-in position line, we can tell Fusion where we want the plasma cutter to start and exit the cut. If we leave this selection blank, Fusion will auto-generate these positions itself, and we can then come back and edit them later if we don't like the auto-generated positions. Fusion will only take a moment to generate the toolpath for us because our part is pretty small and simple. More complex cuts can take longer to generate. Once it generates, if you look to the browser on the left of the canvas, we can see green check marks beside the setup and 2D profile. That means we did everything correctly and there were no errors in the values we used. If you see a yellow or orange triangle, that means one or more of the values that you used in your profile or setup conflicted in some way and you'll need to go back and check them. We can now simulate the cut by right-clicking on the 2D profile that we created and selecting Simulate from the drop-down menu. After simulating the cut, if you're happy with the path that the cutter is set to take, we can then post our toolpath. We can do this by once again clicking on the 2D profile that we created and scrolling down to select Post Process. In the menu that pops up after selecting Post Process, we can name the program that we created. We can also preview the location that the file will go to as we finish post-processing. You'll want to either create a shortcut to this folder or select a new folder for the files to be sent to so that you can easily find them later when you intend to bring them to your Plasma table. When you see the notice pop up that says NC code successfully posted, that means everything worked properly and we can now put our file on a USB key and take it to our table for cutting. Thanks for watching.